The topic is naming angles and angle vocabulary. How do you name an angle? What are some key vocabulary words relating to angles? So this first definition right here is a portion of a line that begins at an endpoint and goes on forever in one direction. And it would look like this. So it begins at an endpoint and it goes forever in one direction. And the reason I know it's going forever in one direction is because of that arrow, okay? And that right there is called a ray. You'll notice that there's two of them. Here's another ray right here. Here's its endpoint. Oops, and it goes forever in that direction also. Let's go ahead and label that. Okay, so now the next one is this little point right here. This little point is the common endpoint where two rays begin. It's also the point where two lines or segments intersect. So not only does this have the same name, but if you have two lines, right here where they intersect has the exact same name. And also if you had just some shape, those points right here also have the same name, okay? And I'm going to tell you that name right now is a vertex. And now I want you to draw this in right here. I want you to draw what's called an arc. So when you see kind of like a little, I don't know, curvy thing right there, it's called an arc. And the silly way I remember it is I think of a pirate, and pirates stereotypically have hooks. So I think of it as an arc. Okay? All right. Let's label that. Okay. Now, the space where two lines or rays meet, it's measured in degrees, it's called an angle. It's measured in degrees. Okay? And that's going to be, you know, this space right here. That opening, that's an angle. All right, now the next part of our notes, you need to know that there's 3 different ways to name angles, and I'm going to expose you to all 3 of them just so that you're familiar with all of them in case you're confronted with them on your assessments or in different math books and things like that, okay? So one way to name an angle is naming it by the 3 points. So if they give you 3 points like that, that's one way to name it. And the way I would name this angle is I'd draw the angle sign. Now that's not an inequality sign in this context because we're specifically talking about angles. So when you see this, that means the word angle, and we can call it angle A, B, C. Or you're allowed to call it angle C, B, A. Okay? But the key important thing is that when you trace it, you're able to trace it, and that vertex is in the middle. It would not make sense for me to go A, C, B, because see how I'm going over that gap right there? So the way to name angles based on their points is follow the points and make sure that vertex is in the middle. So when you're naming it this way, vertex has to be in the middle. All right, so now right here, you'll see that they don't have the 3 points and they just have it right here. So the next way that you can name it is naming it by the vertex. That's angle D right there, okay? Angle D. The third way that you can name an angle is by the arc. So sometimes you'll see that the arc is just labeled, so you'll name it angle E and then degrees, okay? So right down here for your summary, I want you to copy down one of the definitions from above for your summary. So one of those 3 definitions you see up there, I want you to copy it down word for word in that summary in a complete sentence, please. Okay, now go ahead and flip your paper over. Okay, when you see an M right in front of the angle symbol like this, so when you see that, see how there's an M right in front of it? When you see that, this is how you got to say it out loud. You'd say the measurement of angle EFG. and they're telling you is 45 degrees. So here's how you say it out loud. That's why it's in quotes. The measure of angle EFG is 45 degrees. Okay, so when you see that, that means in the context of angles and stuff, that means measurement of angle EFG is 45 degrees. Okay, so here's an example. If the measurement of angle EFG is 45 degrees, draw a sketch of it using a protractor. So a protractor is a tool that helps you measure angles. And here's what it looks like right here. I'm going to go ahead and show you how to use the protractor, okay? So what you should probably start off by doing is I want you to just draw a ray, and for just the sake of this example, let's draw the end point right there, the starting point. And I'm sorry, but it's going to be kind of challenging for me to do this with one hand. And I'm just going to draw oops, hold on, sorry. Whoa, this is really hard. It's supposed to be straight, like that, okay? Okay, so hopefully that's straight. And what you'll do after you draw your ray, you're going to look at your protractor, and you want to make sure it's facing the right side up. See, if it looks like that, that means it's upside down. And you're going to see that little hole right there? You're going to put that hole on top of the vertex, like that. And then you'll see that there's typically a straight line right there. You're going to put that on top of your ray right there, okay? And that's where it would go, like that. And since it's telling us it's got to be 45 degrees, you're going to find 0 degrees right here. And then you'll see 10, so from there to there would be 10 degrees. From an opening from there to there is 20 degrees. And so they're looking specifically for 45 degrees. So I see 45 degrees is right there. But something you're probably also noticing is, hey, isn't that 135 degrees? Well, if it opened from here all the way over to there, that would be 135 degrees. But since it's an acute angle, let me go ahead and show you. So I'm going to put a little tick mark right there. I'm going to take my straight edge, and I'm going to draw it out, extend it out that way. Whoops. To that. Therefore, that is 45 degrees. Okay? 45 degrees. Now, what I was mentioning about that 135 degrees, if I had it extended out here, this opening right here is 135 degrees, okay? Because look, if I put my vertex right on that circle on the vertex, and I match the line on the line, see that opening right there? That's 135 degrees. But this opening, which is obviously acute, is only 45 degrees. So you kind of want to think about that as you're labeling you're using your protractor, okay? So there we go. There's your sketch. And sometimes you might see it like this on a paper where it might look a little bit confusing. Don't be afraid to turn your paper, okay? So same exact method, put your dot on the vertex, line it up, boom, 45 degrees. That opening's 45 degrees. This opening over here, it would be 135 degrees. Okay, so the next example, it says label the degrees of the angles below using this information. So this is kind of practicing what, practicing the 3 ways, or practicing a way to label your angles. So the measurement angle TWQ is 111, so you're going to find TWQ, and I want you to draw an arc. Or no, let's not draw the arc yet. Let's just go ahead and label it. Okay. And then XWT, go ahead and label that. And then QWR, label that. And then PWR, label that. And XWP, go ahead and label that. This is what it should look like. Don't just copy me, try this before, okay? Before I show you. Okay? So here's something I want you to think about right here. I'm going to draw the arcs and I'm going to connect the arcs. So this opening right here, this angle is 111 degrees. And this angle right here measures 34 degrees. And this angle right here measures 35 degrees. This one measures 111 degrees. And this one's 69 degrees. Okay? And look when I connect the arcs. What shape do you see right there? When you see that shape, you should be thinking, oh yeah, that's a circle. And so I want you to think about how many degrees, just from your prior knowledge, how many degrees are in a circle. Okay, now I want you to add this up. What's 111 plus 34 plus 35 plus 111 plus 69? What does that equal? You should get 360 degrees. That's your answer, okay? So make that connection. You see all the arcs connected? That should equal 360 degrees. Now look right here. That right there, it's a half a circle. So think about how many degrees would be in half of a circle, okay? Just think about those for now. All right. My question is, what mathematical tool helps you measure angles? Go ahead and fill that in, please. Okay, and I'm going to go ahead and migrate to a different part of the room. Okay, so the next part of our notes I want you to know is the definition of adjacent angles. Those are two angles that share a vertex and a ray or line. They're right next to each other in touch. Here are some examples of adjacent angles. So adjacent just means they're right next to each other. They touch, okay? So see how that these right here share, A and B, angles A and B. They share this vertex and they share this ray right there, and they're touching. That just means they're adjacent. They're right next to each other. Next example is angles C and D. Those are adjacent. See that they're right next to each other, okay? They share that line right there. Angle E and F, those are also adjacent. They're just right next to each other, okay? The next vocabulary word that I want you to know is vertical angles. These are non-adjacent angles that are directly across from each other. If you trace the straight lines forming one angle, they will be the same as the ones forming its vertical angle. So go ahead and write that down. I'm going to show you a picture of it, okay? Oh, this is very, very, very important. Vertical angles are always congruent. And see that weird looking symbol right next to the word congruent? That means congruent, okay? It's like a little equal sign with a squiggly above it. Congruent means same size, same shape, same angle measures, okay? So vertical angles are always congruent. So here's the example. Okay, so the question says which angles are vertical? And like it said above in the notes, if you trace the straight lines forming one angle, they will form the same as the ones forming its vertical angle. They will be the same as the ones forming its vertical angle. So if I'm like, A and D, they look like they're right across from each other. I'm going to go ahead and trace the straight lines for A, okay? So when I'm tracing that, it goes straight, 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 okay? And then the other one for A, straight, 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 straight. And you'll see that the two ones that have the blue, they match, okay? So A and D are definitely vertical to each other. Something else you want to see, if you're curious about, hey, is angle E and angle B, are those vertical to each other? They're totally right across from each other. But here's how you check. If you're curious if E is vertical to B, you're just going to trace its lines straight, 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 straight. Okay? So far it matches up with one of the lines that forms angle B. Now the other one that forms angle E, oh, you gotta keep it straight. You can't just bend it. You gotta straight. Okay, so unfortunately, E is not vertical to B, and E is not vertical to C. But A and D are vertical to each other because when we did the straight, 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 they are matchy, matchy, okay? So what I know about vertical angles is if this was, hypothetically, if it was like, I don't know, 86 degrees, then this one would also be 86 degrees. Because vertical angles are always, always, always congruent. Okay? So which angles are vertical? Just angles A and D, or you could say angle D and A. So what I want you to write for your summary, I want you to write about what's so special about vertical angles. Okay? What's so special about vertical angles? All right, and you're going to flip over your paper. So the next vocab word that you need to know for this unit are complementary angles. Complementary angles. Here's how you spell it. C-O-M-P-L-E-M-E-N-T-A-R-Y. Complementary angles. And those are two angles whose degrees add up to exactly 90 degrees. Please memorize that, okay? So now I'm just going to draw some angles here, and they're not going to be drawn to scale at all because I'm not going to use my protractor to draw them. I'm just going to give you what I want you to, I'm just going to give you what the angle measures are. Okay, let's pretend that this right here is 30 degrees, okay? And this one right here is 60 degrees. I'm telling you that. If you took a protractor out and measured this, it's probably not right, but I'm just telling you this for the sake of learning, okay? So 60 plus 30 is 90. So I know that this big old angle right out here, that is 90 degrees. So therefore, that 60 degree angle plus that 30 degree angle, since their sum is 90 degrees, I know that these two angles are complementary. So this is a complement to this one, because their sum is 90 degrees. Alright, let me try another one if I drew it this way. And does that look like a 90 degree angle? Some of you might argue, yeah, sure it does, but don't ever assume. It must have a box, or it must literally say, hey, this is a 90 degree angle. If it's like that, but it looks like it's a straight angle edge where it looks like it's 90 degrees, don't assume. It's in math problems, okay? Don't assume. They have to explicitly tell you, okay? Or you have to, it might say like, use your protractor, measure this. And if it measures to 90 degrees, then yeah, you're good. Okay, so let's pretend that, I got that ray out there, let's pretend that this is 10 degrees, which is totally not 10 degrees because I don't have my protractor to measure it. And this one's, that's got to be 80 degrees. They're complementary angles because 10 plus 80 equals 90 degrees. Those are complementary angles. So this right here is a complement. And this 80 degree angle is also a complement because together they're complementary. Okay? And how about this right here? If I had, pretend that's 45 degrees. And then this one right here, pretend that's also 45 degrees. Are those complementary angles? Yes, because they both add up to 90 degrees. They don't have to connect. Since 45 plus 45, since their sum is 90, they're both complementary angles. So that's a complement. And that one's a complement. And together they're complementary, okay? So please remember, two angles whose degrees add up to exactly 90 degrees, they're complementary angles. Okay, you'll see that the next section is divided into two columns, and there's a reason for that, because you'll find that supplementary angles and linear pairs are pretty similar. There's just one tiny difference. Supplementary angles are two angles whose degrees add up to exactly 180 degrees. Two angles whose degrees, or you could say angle measures, and the definition for linear pairs is they're two angles whose degrees, or angle measures, add up to exactly 180 degrees and have to be adjacent. Okay, so that's the difference, this part that we're adding right here. And they have to be adjacent. So they have to be touching. They have to share a side. Alright, so we're going to go ahead and sketch just some examples. Here's some supplementary angles. Okay, this is not drawn to scale because I obviously don't have a protractor in my hand. Okay, so this is 89 degrees and this is 91 degrees. These two angles are supplementary because 89 plus 91 equals 180 degrees. So this 89 degree angle is a supplement to this one right here. These can also be touching. Supplementary angles can be touching. You know, they can also be adjacent. So if this was 90, this one's 90. So 90 degrees plus 90 degrees equals 180 degrees. So this is a supplement to this angle right here. It's a supplement too. Together they're supplementary because they add up to 180 degrees. Let's draw another example. Just a quick sketch. Again, it's not drawn to scale. So if this one was 30 degrees, how many degrees would this one have to be? They got to have a sum of 180 degrees, so if this is 30, this one has to be 150 degrees. Because 150 plus 30 is 180 degrees. So this is a supplement, and this is a supplement. And let's draw another example of supplementary angles. Again, they don't have to be touching. Oops. I'll make this one kind of a big angle like that. Now let's pretend this is 110 degrees, and then its supplement would have to be 70 degrees, because 110 plus 70 equals 180. So this 110 degree angle is a supplement to this guy right here. That's a supplement. Together they are supplementary. So for supplementary angles, the angles don't have to touch, but they can. So the angles don't have to touch, but they can, and they are called supplementary angles. I'm going to put an equal sign because that means supplementary angles. Alright, let's go ahead and look at some examples for linear pairs. Again, linear pairs are two angles whose degrees or angle measures add up to exactly 180, so similar to this, but they also have to be adjacent, so they have to be touching. So here's some examples. So let's say this is 160 degrees. If that's 160 degrees and I'm saying that they're linear pairs, this one has to be 20 degrees because 160 plus 20 is equal to 180 degrees. And here's another example of a linear pair. Let's pretend this is 145 degrees. Then this one would have to be 35 degrees because 145 plus 35 equals 180. So those right there are linear pairs. And here's another one. It's going to look like this. I'm just going to use the boxes right there so you know this is 90, this is 90. And those are linear pairs because they're adjacent and they have a sum of 180 degrees. So the bottom line with linear pairs, the angles have to share a line, they have to share a vertex and a line or a ray. In other words, they have to be adjacent in order to be linear pairs. So I'm going to find a spot to write that. The angles, to be linear pairs, have to share a, oh, my pen's dying. Share a vertex and line or ray. So they have to share this right there. In other words, that means being adjacent. You know, they have to share a side in order to be a linear pair. Okay, so down here for your summary, it says describe complementary angles. If you already forgot, go ahead and review the notes on this page. And then down here, I want you just to describe supplementary angles. If you don't remember, reread the page. Now turn the page. Okay, up top, see these examples right here? These are called angles on a line. Okay, so see how they are all on this line, they all touch that line. Here's a straight line, they all touch it, they all share that right there, okay? And when you add up all the angles on a line, they're going to add up to, we'll go ahead and check. What does 25 plus 75 plus 80 equal? What does 35 plus 30 plus 65 equal? What does 49 plus 51 plus 30 plus 50 equal? 180 degrees. So these angles right here, when you add the angles on a line together, they'll have a sum of 180 degrees. Okay? One way that I like to see angles on a line when I look at them is I can see that if I had just a straight edge right there, see how they're all along that line right there? So they would have a sum of 180 degrees. There's another one right there. And right there. Another thing that could also help you think about this is when you connect all their arcs, see the shape that's formed? It's half a circle. And since a full circle has 360 degrees, half of a circle would have 180 degrees. Okay? So that's what angles on a line look like. If one was missing, since you know the sum is 180 degrees, you can find that missing number. Since 75 plus 25 is 100, I know that they equal, that all three of them have to equal 180, and when added together, I know that this missing one would be 80, since this is already 100. Next section, see these right here? See how they're a little bit different than the ones above? How they all meet at a vertex, right there. So I want you to figure out what these all add up to. Add all their arcs together, all the degree measurements. Look at the arcs. When I connect all their arcs, what shape do you see? It's a circle, okay? And how many degrees are in a circle? 360 degrees. So these angles right here are called angles at a point, because they all meet at a point. Okay, they all meet at that vertex, okay? So when you have one that's missing, you know that all together collectively they have a sum of 360 degrees. So what you could do is add up all the ones you do know, take that number and subtract it from 360 to figure out the missing one, okay? So this plus this plus this plus this, 65 plus 115 plus 65 plus 55 should equal 300. So this missing one, if I didn't know it, would be 60, so that they would have a sum of 360 degrees. Okay, for your summary. Angles on a line have a sum of blank degrees, fill it in. Angles at a point have a sum of blank degrees, fill it in. Okay, bye.